Log equations. All right, we have two here. First one, log base 8 of x equals 2 over 3. And we're looking to solve for x. So we can convert this to an exponential equation. And to do that, we use what I call the scorpion rule. So it's the base to the power of what the log equals is equal to the argument. So to convert this log equation to an exponential equation, we could write 8 to the power of 2/3 is equal to x. 8 to the power of 2/3 equals x. Now these are equivalent expressions, right? But in doing this, it takes the x outside of the log and makes it easier to solve. All right. And now 8 to the power of 2/3. So, we can do that on our calculator. So let's just do that now. But I'll show you what it means in a second. So 8 to the power of brackets 2 divided by 3 gives us 4. So we know x will actually equal 4. But if you're wondering about that fractional power there, so when we have, let's focus on 8 to the power of a third. Right? That is the same as the cube root of 8. So the cube root of 8 is 2. However, if it's 8 to the power of 2 over 3, it's the cube root of 8, but it's now squared. So that will become 4. Right? So therefore x equals 4. All right, now part 2. They've given us, whoa, look at all this space. Yeah, this one's definitely an excellent question. So solve this equation. 6 times brackets log base 8 of x squared plus 2 times log base 8 of x minus 4 equals 0. So immediately I see this squared here. And you might be thinking, the log law where we have, let's say, 10 to the power of x, where you take the power and you multiply it out the front. Right, that's a pretty common approach for solving log questions. However, notice the brackets here. So it's actually the whole log term squared, not just the x. So we can't actually use that log law. I do notice log base 8 of x appears twice though. And this kind of looks of the form ax squared plus bx plus c equals 0, right? A quadratic. So what we can do here is what's called solving by substitution. So solving by substitution. And that's where we let some variable, usually u, just so we don't confuse it with x, equal to, in this case, log base 8 of x. And then in this equation, we replace every log base 8 of x with u. So that becomes 6, instead of log base 8 of x, it will be u squared plus 2 times u minus 4. Now notice how much more simple this problem looks, right? It's just a simple quadratic equation, which we can solve on a calculator. So menu, equate for equation solver. The reason why I'm doing it on my calculator instead of by hand is because this question isn't specifically testing your quadratic solving ability, right? We've done the key step of starting to use substitution, so this will just save us a minute or two. So menu, equate for equation, F2 for polynomial, degree 2 for quadratic, and we put in a, b, and c. In this case, 6, 2, and negative 4. And we hit F1 to solve, and we get x, or in this case u, equals 2/3 or negative 1. Alright, so we've solved the equation. Well, we've solved this equation. right? We haven't solved the original equation. So what we need to do now is what's called back substitute. So we made this substitution, but now we need to convert our u solution in terms of x. So u equals 2/3 is the same as saying log base 8 of x equals 2/3, right? Is that log base 8 of x is u, and we found out that u must be 2/3. It's also the same as saying log base 8 of x equals -1, because we had two solutions for u. And now we can solve for x. So here we have, that looks familiar. Wow, that is just the same as part 1, right? So 8 to the power of 2/3 equals x. And so x equals 4. Great. And now on the other side, we have 8 to the power of -1 equals x, which 8 to the power of -1 is the same as 1 over 8 to the positive 1, or just 1 over 8. And so our two solutions for that equation, that log equation, would be x equals 4 or x equals 1 over 8.